Let's take a look at the questions on the Unit 6 test review. The population of a city can be modeled by the function p of t equals 3810 times the quantity 1.0005 raised to the 7t power, where p of t is the population after t years. Which function is approximately equivalent to p of t? Well, let's take a look at the initial values, okay, which are different with some of these answers. Take a look at the rates of growth or decay, which are different for some of these answers. And most importantly, the power of t is the same for everything, but that's not what it was in the question. So that's the main difference here. The main difference is, how can we get this 7t power, which is 7 times t, to be just a t? This question is actually a properties of exponent question, not an exponential growth or decay question. These examples are exponential growth and decay, but we're looking for what happens when I want to simplify this item. If I have something like x to the 5th times x to the 3rd, it's equal to x to the 8th because I add those powers. But if I have x to the 5th raised to the 3rd power, then that means I actually multiply. I'm actually going to multiply that exponent. So if I have 1.0005 raised to the 7t power, or 7 times t power, then I can take this 7 and multiply it by the power for 1.005, which is 1. This is an equivalent expression, because in order to simplify this, I could multiply this power there, and I would get 7t, right? I can put them together. So what I need to do is calculate this exponential base and power. So I'm going to open my calculator here and type 1.0005 raised up to the 7th power. And I get 1.0035. So I know that my growth here has to be 1.0035. And the question is, which one of these items will it be? Right? So if you're equivalent, and this is growth, these were definitely, because these items are lower than 1. That's decay. But now that we've used our properties of exponent rules here, we can see that this will change only the quantity in the parentheses. It will not change the quantity in front. So this is a changed quantity. This is not. So the answer for the first question is 2. Number 2, if a sub 1 is 6, and the answer for any number, a sub n, is 3 plus 2 times, do you remember what this means? Previous number, right? So 3 plus 2 times the previous number squared. So if a1 is 6, then a2 will be 3 plus 2 times the previous answer squared. Plus 2 times the previous answer, which was 6. Type that in your calculator. 36 times 2, 72 plus 3, 75. But I would turn my calculator on, and I wouldn't try and do that in my head because I don't want to make a mistake. And I would simply type exactly what I see on my paper here. Right, just like that. There we go. Number 3. The function f is shown in the table below. Which type of function best models the given data? Well, I can see here that this grows by rates of 1, and this one goes up by 2, but then it goes up by 6. Then it's definitely not linear. And cross off anything that says linear. So now I can try exponential here, and that is timesing by a positive 3. That's a whole number, so that's growth, which we can see as x increases, y increases or f of x increases. What is the common ratio of the geometric sequence whose first term is 5 and whose third term is 245? Wrong place. 5, 2, 5. So this is different than a common difference. This is some type of timesing pattern. And because it's a geometric sequence, I can find that pattern by dividing 245 by 5. And when I do that, I get 49. And because I am multiplying something by itself, I can square root this 49 to find that multiplier. So the multiplier was 7. And if I didn't know that, I could have just tried all of these by guessing and checking. The answer is 7. Question number 5. If the pattern below continues, which equations is a recursive formula that represents the number of squares in the sequence? So recursive formula is when you need your previous answer to get to the next answer. So my first answer has 3, or these 3. And then I had 2. And my last answer had all of these, and then I had 2. Right? 2, 4, 6, 7, 2, 4, 6, 7. My last answer had all of these, and I added 2. So it looks like my a sub 1 is 3, so that checks out. That does not. So that's gone already. And it looks like each design is increasing by 2. Previous number plus 2. Previous answer plus 2. So this one works right here. It said it was recursive, and these here are arithmetic. A high school sponsored a badminton tournament, and after each round, 1/2 of the players were eliminated. That's decay, right? It's getting less each time. If there were 64 players at the start, so that's our initial value, 64 players to start, our rate of decay is 1/2, 1/2 of the players. 1/2 is also equal to the decimal 0.5. So which equation models a number of plays after 3 rounds? Well, 3 is the time. So if the exponent is 3, these are out. And if the initial value is 64, and we have decay, then we are subtracting. Decay is subtracting. The equation v of t equals 12,000 times 0.75 to the t power. This represents the value of a motorcycle t years after it was purchased. Which statement is true? Well, let's focus here. Initial value, then decide, is this growth or decay? Well, it's less than 1, so it is decay. It is depreciating. And don't forget, this is the decimal representation. This is not the percentage representation. If you want to put a percent sign next to this number, you have to move the decimal twice. Okay, so the motorcycle cost 9,000 or 12,000. Well, this is definitely wrong. The motorcycle cost 12,000 when it was purchased. That's true. The motorcycle's value is decreasing at a rate of 0.75 each year. Now, I know that is 75 and this is 75, but when you have your formula, it's supposed to start with a 1, right? So 1 minus something is going to give me 0.75. So if it was decreasing at 75% each year, then it would be 1 minus 0.75, not just a 0.75, right? Not just a 0.75. So this one is out. This one is out. We know this was true, but I want to talk to you about why this one is not true. This one is not true because if the decay is 0.75, oh, sorry, wrong. If the decay is 0.75, and the original formula was something like this, and if you decay at 0.25% each year, then to put this number in, you would have to move that decimal 2 more times. And 1 minus 0.0025 is not that number. The answer is 2, but now you know why these are wrong. Number 8. Given the following 3 sequences, which ones are arithmetic? All right, so let's see here. Plus 2, plus 2, plus 2, plus 2. This is definitely arithmetic, so that's out. Plus 2, plus 4, plus 8. This is not arithmetic. That's a timesing pattern, timesing by 2. So anything that has a 2 in it is out. Oh, I guess we found our answer, but let's prove it. A, this answer, and then A plus 2, okay? So the previous answer would be A plus 2 plus 2, which is A plus 4, very good. Then if I take this and I add 2 more, plus 6. If I take this and add 2 more, plus 8. So that is the right answer. Number 9, the population of bacteria can be modeled by the function f of t equals 1,000 times 0.98 to the t power, where t represents the time since the population started decaying. And f of t represents the population of the remaining bacteria at time t. What is the rate of decay? Don't forget, it had to have started as something like this, right? It had to have started as something like this. So if you're decaying 98%, you are subtracting 0.98. If you're decaying 2%, you're subtracting 0.02. If you're decaying 0.98%, you're subtracting 0.0098. If you're decaying 0.02%, you're subtracting 0.0002. So these are the choices of the numbers that would be in this position. If I have to get a 0.98 when I'm done, then 1 take away 0.98 cannot be the right answer. 1 take away 0.0002, 1 take away 0.0098, no. So the answer here is 0.02, which is the 2% decrease, right? So if 100% is 1.0, you take away 2%, that's how you get to 90.98. A laboratory technician used the function t of m equals 2 times the quantity 3 raised up to the 2m plus 1 power. Consider these following expressions. Okay, this looks like an exponential function, but this question is a properties of exponent question. So the only way to add exponents together, is if you originally had the like bases and these two items added together. So x to the third times x to the fourth equals x to the 3 plus 4. Now I know I can put these together, but my original equation was 3t times x to the 4. And my answer would be 3t plus 4, like that. Just like we have here. So what I'm going to do is I'm going to take this plusing exponent, I'm going to work it backwards. That means this used to be 2 times 3 to the something power times another 3 to the something power. And what were the two powers? Well, they were 2m and 1. Well, I can simplify this. So 2 times 3 to the 2m power times 3. And these, although they're not like bases, they don't have any powers. Oops, sorry. So I can certainly multiply them together. 2 times 3 is 6, but this would still be there. Whether I put it inside or whether I put it outside, the parentheses doesn't matter. So this is definitely equivalent. And let's check on these other ones. Okay. Erase this to give me some space down here. And let's see if I can't change this power any at all. So right now it's 6 times 3 to the 2m power, also known as 2 times n. 2 times m is something that you get when you raise a power to a power like that. So this is 3 times 4 is 12, or 3 times 4. So before I got to this power used to be inside. So it looks like I can write this like that as well. And 3 to the second power is also known as 9. So this one is also true. So the answers are 1 and 3 only. 1 and 3. Population of paramecia can be modeled using this exponential function, where t is the number of days since the population was first observed. Which domain is most appropriate to use to determine the population over the course of the first 2 weeks? Backwards here, the domain is an input, or an x value, right? And for us, x is t. So t is time. Which domain is most appropriate to determine the population over the course of the first 2 weeks? So the time is from 0 past the first week all the way up to the second week and stop. So that domain has to be between 0 and 2, which is answer 3. A recursively defined sequence is shown below. What's the value for a sub 4? Well, it looks like a sub 1, 5, 2, sub 3, sub 4. Well, a recursive function requires us to use the previous value. Well, let's see. Okay, so if I want to find a sub 2, I'm going to put a 2 here, I'm going to put a 2 there. So the answer for a sub 3 is 2 times a sub 2 minus 7. But I don't know a sub 2 yet, so it looks like I need to back up. Let's put a 1 here. The answer for a sub 2 is 2 times the answer for a sub 1 is 7. And the answer for a sub 1 is 5. So 2 times 5 is 10. 10 minus 7 is 3. Now we can do the answer for a sub 2 plus 1, also known as a sub 3, is 2 times a sub 2, I'm plugging in a 2 here, minus 7. 2 times a sub 2 is 3, minus 7. So it looks like I always do 2 times the previous number, take away 7. 2 times the previous number is 6. 6 take away 7 is 1. So now I'm going to do this math again. 2 times the previous number, take away 7. 2 times the previous number, take away 7. Negative 2 minus 7 is negative 9. Jill invests $400 in a savings bond. The value of the bond in hundreds of dollars over X years is illustrated in the table below. So let's see here. This is increasing. It's definitely going up. So I'm going to say here, it grows, it decays. Nope. It grows, it decays. Nope. All right, so I only have to choose between these two. Now let's say that again. Is this growing or decaying? We said it was growing. So let's look at this number. Is that a growth number? No. That's out. The answer is definitely 3. But if you weren't sure, you simply turn on your graphing calculator. You enter this information into the stat edit feature here, stat edit. You have 0, 1, 2, 3. And in the second list, you have 4, 5.4, 7.29, and 9.84. You stat, calc, exponential regression, which is off the screen. Now letter number 0 here. You press enter several times, and it looks like it's 4 and 1.35. Yep, so we were right. On the day Alexander was born, his father invested $5,000 in an account with a 1.2% annual growth rate. Write a function a of t that represents the value of the investment after t years. All right, have to write parentheses t, not a y. Okay, do we know the initial amount? Yes. Do we know if it's growth or decay? Annual growth rate, plus sign, and we know it's after t years. So let's turn this into a new decimal by moving it twice. 0, 1, 2. Determine to the nearest dollar how much more the investment will be worth when Alexander turns 32 than when he turns 17. Okay, well, first, figure out how much it will be when he turns 17. Plus 0.012, 17 years. Figure that out. Then figure out how much it'll be worth when he turns 32. Plus 0.012 after 32 years. Get your calculator. All right, here we go. 5,000 parentheses 1 plus 0.012 raised up to the 17th power. And because this is money, I'm going to round it to the nearest penny. So it's going to be worth $6,124.05. And I'm going to go up here and copy and paste. Change that 17 to 32. And it looks like when he's 32, it'll be worth $7,323.97. 7323.97. Take away 6124.05. So I write that down. 7323.97. Take away 6124.05. And I justify my response just like that. It will be worth approximately $1,199.92 more. And that's all I need to write. Given the recursive formula, a sub 1 is 3. State the values of a sub 2, a sub 3, a sub 4. A sub 1 is given. A sub 2, a sub 3, a sub 4 need to be found. And it looks like I'm going to do 2, previous number, and then 4. So it looks like I'm going to have 2 times previous answer plus 1. So this one will be 3 plus 1 is 4. 4 times 2 is 8. Then my next one will be 2 times the previous number plus 1. 8 plus 1 is 9. 9 times 2 is 18. And my next one will be 2 times the previous number plus 1. 18 plus 1 is 19. 19 times 2 is 38. Okay, last question. Nora inherited a savings account that was started by her grandmother 25 years ago. This scenario was modeled by the function 5,000 times the quantity 1.013 to the power t plus 25. Which function below is equivalent? This is a property of exponents rule. So the only way to add exponents together is if you add this item 2 times and you added this power to that power. Right? So the 5,000 is in the front, and then we had these 2 powers timesing each other, which is how we were able to combine them into an addition statement. So nothing happens to the 5,000. It's just this common base that we kept the same, and we shrank the exponent. That is not right. This one is right. I apologize. All right, be careful and looking at your choices.